Thank you. Can you all hear me fine? Perfect. Simon's not kidding. I get really nervous when I talk, so no sudden moves because I may have an accident. So I'm head of development here at iRexchange, and I wanted to talk to you today about a case study from our startup. And I wanted to talk to you about how our architecture evolved over the last 3 years. We went from starting with a monolithic architecture, which had a bunch of problems for us. And so we adopted microservices, which had a whole bunch of new problems. And we ended up with something in the middle that, for this talk, I've called a distributed monolith. And it's a case study, but I don't want you to take what we did and apply it in your organization. That would be bad. That would not be a good outcome. Sometimes I think my role in life is to be a cautionary tale for others. And in this case, what I want to do is share all the things we got wrong so that you can learn from our mistakes and do it better in your own organization. So if you do these things, please don't call me up and say, we did what you said and it's a disaster. I'm warning you now. Let's try this one. So a little bit about the company. iRexchange has been around for 3 years. We are a technology company trying to disrupt traditional wholesale and retail in the grocery space. So we want to use new technology and new ideas around moving goods to eliminate the wholesale concept of the middleman in retail. We're doing really well. We've raised over 40 million in investment capital. And in terms of all of those metrics, new customers, number of orders, number of revenue, customer satisfaction, they're all heading in the right direction. It's really a good news story, and I'm really proud to be part of it. But all of that business growth and achievements has been built on top of the technology delivery that we've achieved over the last 3 years. And what I want to do is talk about the technology, or just one part of it. When you look at our platform, there's really 3 bits. There's a analytics and business intelligence engine that gives us insights and tells us what to do next, and starting to get into machine learning and forecasting. And sitting on top of that, there's some proprietary software managing our flow through of goods, physical goods from suppliers to a distribution center and out to retailers. But on top of that, there's a B2B portal, a very traditional two-sided marketplace where suppliers and retailers interact with each other. And what I want to talk to you about today is just that platform and how it evolved over time. So I want to talk about the architecture and how we evolve the architecture. So the first thing you need to do is sit down and understand with your business, look, what are the architectural requirements? What do we need for this system to be successful? And pre-cloud, it was pretty simple. Fixed hardware, you could say performance, reliability, or cost. Pick 2. Nowadays, in the cloud, there's an incredible number of capabilities that you can achieve with what you're building, and they want everything right at the start. I want, scalable, performant, cheap, evolvable, secure, etc. And you can't deliver everything all at once. So you need to have a conversation. Actually, what's most important? And this is the bit where, as the technical team, you need to really understand the business and the business domain and what they're trying to do so that you can pull out things that are more important that you're going to enable first with your technology delivery. For us, for our startup, where cash burn's a thing, we had 2 clear priorities. The first one was speed to market. We needed to deliver new features to our users as quickly as possible. And once we had those features in front of our users, we needed to measure and learn, see how they're using them, and iterate on those features also as quickly as possible. And lastly, if there was a defect or a problem in production, we needed to identify it and resolve it even faster, because we couldn't afford to have things stick around for a long time if they were slow. So we define that in terms of capabilities as ease of change and automated. Automated, build, package, deploy, all of that. The second driver was minimize reputational damage. If we had a data breach and lost customer data, if the performance of the site was slow, or if we were unavailable, any one of those events we might not recover from in terms of winning back the trust of our customers and be able to keep doing business. So any of those things would probably finish the startup. So now we know what our architectural needs are: speed to market, minimize reputational damage. What sort of architecture do you need to build that? We thought we'd ask the experts, and this was the answer: microservices. Unfortunately, we didn't know a lot about microservices at the time. So, like all good technologists willing to learn, no, just leave that off. We bought the book, did the workshop, which I highly recommend, and listened to a bunch of keynotes. And out of that, we thought we knew a lot more about microservices. In particular, we now knew that instead of drawing our architecture like this, we could draw it like this, which looked so much more modern and cool and fancy and exciting. And here's the thing, right? Microservices are quite seductive in what they offer you in terms of capabilities. They abstract away all of the hard stuff around networking and logging and monitoring and alerting, and you can scale things independently and deploy them in easily and make changes and all of that. And it sounds really, really nice. If you're an architect and you like drawing boxes and clouds, then adding hexagons to your template and designing a new architecture should be fairly simple. The reality is, it's a little more complicated, and that's what I want to talk to you about today. So, a little bit of background context. When I started at iRexchange 3 years ago, we had acquired a system, a warehouse management system, that had been modified to demonstrate our unique business workflow. And when you looked at it, it sort of looked like this. It's a two-sided marketplace. There were suppliers and retailers. Underneath that was our logistics and fulfillment teams. And the system itself, it had these capabilities that sort of represented the domain concepts in two-sided retail marketplaces. And it was tied together by a bunch of business processes. And we looked at that and said, yeah, okay, we understand the business and we understand the domain. And if we do a little bit of domain modeling, because we really like Eric Evans and domain-driven design and bounded context and all that stuff, if we do a bit of domain modeling, we can see that there's 3 clear bounded contexts: suppliers, retailers, and stuff around logistics and fulfillment. So this was our conceptual architecture. The physical architecture looked like this. It was a 2-tier monolith, Java sitting on top of SQL Server on physical infrastructure. So our first step was to move this into the cloud, for us, AWS, and start to knock off those architectural requirements that we had, right? So we moved it into AWS, and we moved the Java application into a Docker container and SQL Server to RDS, and basically just a standard migration into AWS, and we leveraged all of the things that AWS gives you to solve those don't screw up your reputation triggers, right? So scalable, we could adjust the instance size of what we were running on. Resilient, well, we're in 2 availability zones and we have auto scaling groups and all those things that give you resilience. Secure, server-side encryption and VPCs and bastion boxes and a whole heap of other things that made it secure. And so we could tick off those boxes and we could go, these are the patterns we're going to use for everything we do going forward, so we will always have these boxes ticked off. And having done that, we could start to think about the main requirement, which was speed to market. So here's the thing, right? Even though we're in the cloud, it's still a monolith. And what we're trying to do is ease of change and automate it. here's the thing, I actually like monoliths. If I was starting a startup from scratch and I wanted to put a product in the market and get feedback as quickly as possible, I would build a monolith. Who else likes monoliths? Anyone? That is really nice to see. And the reason is, all your stuff's in one place. There's only one thing to deploy, all your dependencies are there, you understand what the changes are. It's fantastic. But it only really works if it's a well-written monolith. TDD, separation of concerns, all those nice OO things we learned about in the 80s and the 90s. Because then it's a great way to start. We had a little problem with this one. And the problem was that it had been designed to be lightning fast. And the way the people who had written it did that was they put all the business logic in the stored procedures. And it was super quick. But there were no tests. And for new developers looking at it, it was really, really hard to understand. And every time we made a change, we broke 10 other things, and we could not predict what would break when we touched it. So we had to deal with this, and we talked about ways and options of doing this. And finally, we said, actually, let's just not touch that legacy thing. And here's the thing, we're a startup with legacy software, not a good place to be. Let's just write some new services with all the business logic we want, and the UI can talk to them, and the services can talk to and read and write from the database, and we'll ignore all the existing stuff in the middle. We'll keep using it, we need it, but we won't try and change it. That's the Strangler Vine pattern. It's very common, and I highly recommend it. It's a great pattern for this sort of code. And so what that did is it gave us ease of change. And then we used all the standard tools, Bitbucket, BuildKite, which is awesome, CloudFormation, automated how we built all of this, and then we had automated as well. So life was reasonably good. The team was focused on writing new business logic in these new services, sitting inside this cluster, delivering what we need for our deadline. It sounds easy when I say it. I just want to say, though, that 3 years ago, when we started using these technologies, Docker was reasonably mature. Managing containers and clusters was not mature. And we lost a lot of time and money trying to find tools that would do a good job of managing containers and clusters. And one of the other challenges as you embrace these new technologies is you have to look at how mature is the tools and the technology around it so that you can actually do what you need to do and do it in the right time frame. Things were going well. It was July. It all looked good. In August, we realized this. I knew when I started that we had a deadline. We needed to be live with the system trading by the end of November. And the reason is Christmas and January is the biggest trading period for groceries. We needed to be in market so people could buy through us. When we looked at how we were going, we had no chance of hitting that date. We needed to do something, and for us, it was scale up. So we went from 4 or 5 devs to 24 engineers over the period of a month. So I had 2 new capability requirements for my system. Team scale, we had to launch, and for those people then, speed of learning. How would they learn the system as quickly as possible so they could be productive? So for speed of learning, we did 2 things. The first thing is we hired really, really expensive consultants who were really, really experienced with all of the technologies that we were doing. And then we put them through a 2-day boot camp explaining the domain and the code and everything else as much as we understood it so that they could then work on the systems. And we just relied on the fact they already knew Java and Spring and Hibernate and AWS inside out. We also said, stay away from the legacy monolith, just work on the new stuff, which made it easier. And that gave us speed of learning. But then we had team scale. We had 24 people. 3 teams of 8 sounds about reasonable, especially if you read the books that say a good Scrum team should be about 7 to 10 people. And we looked at our architecture model and said, well, we've got 3 domain groups, bounded contexts. Let's have 3 teams, suppliers, retailers, and fulfillment, and we'll point them at a bunch of services that relate to suppliers, retailers, and fulfillment. And that way, each team can focus on delivering the value and capabilities that segment, the retailers or the suppliers, needed, right? So we did this. We took our services and we split them out into 3 groups: retailer services, supplier services, fulfillment services. We still had the legacy stuff over on the side, and we basically said to the 3 development teams, you've each got your own set of services to own. Start writing stuff. And that gave us team scale. It was all good for about a week, and then I was managing cost, and then all of a sudden our AWS costs doubled. And I was like, what's going on? Well, we'd built all these nice scripts for spinning up environments, and so people were. No one was turning them off. Secondly, we're oversizing the instances of the systems that we were running, and so we were paying a lot more for infrastructure than we needed to. And thirdly, and probably most important, we weren't thinking about running cost when we were designing our systems. If you're used to fixed infrastructure, you've already paid that cost. You don't normally think about that as you do your software design. In this instance, in the cloud, running cost is a first-class citizen, and you need to introduce it to your design discussions. And because we didn't do that, we had designs that weren't cost-effective. So how do we fix the problem? Well, we started talking about cost and design decisions. We found some open source software to turn things off, and we started turning things off at night, which was good, and turning them back on in the morning. And then we realized we had a problem, because as the tools and everything else evolved, that open source software no longer worked. It didn't stay in sync with ECS, as an example. So then we had to dedicate someone, one of the DevOps engineers, to keeping the tools working, and so that we could turn things off at night. And I'm like, hang on a sec. Why am I now paying my very expensive consultant to modify someone else's open source software to do something that isn't really core to us, right? And from this, we sat down, thought about it, and came up with one of our core principles. And that principle is build your core IP, super important. But don't build any non-core IP. And I think as technical leaders, so for everyone in the room here, part of your job as a leader is to help people decide is what they're working on core or non-core. And if it's non-core, what can you do instead of building it yourself? And for us, we came up with a second principle, which was borrow, sometimes steal, before rent, before buy, before build. So we would use open source software in preference to SaaS software, in preference to licensing something, in preference to building it. For the turning stuff off, we ended up moving to Gorilla Stack, which is Rent, it's a SaaS product. It's fantastic. They worry about keeping it working with all the things that we use and all of the AWS technologies that keep evolving, and we don't have to think about that anymore. Just pay the bill every month. So life's looking a little bit better. We've solved that problem. It was September, we're heading for November, and we were getting slower and slower, and we did not look like hitting our deadline. And when we dug into it, the reason was a little bit complicated. To deploy a service, you needed to deploy all the infrastructure, the AWS infrastructure that went with it, right? And the AWS infrastructure you needed was things like S3 buckets and Lambda functions and queues and databases and all of this. And so what we had for each cluster was an infrastructure project. And every time you deployed the service, you deployed all the infrastructure with it. But the infrastructure needed to be configured, so you needed to manage your environment configuration and everything else and deploy things in the right sequence so that the queue came up before the service and could find everything it needed and all of this. And what it meant was deployments started taking longer. And because they were taking longer, the team started to batch the changes, because If it was going to take 2 or 3 hours to deploy it and then confirm it in an environment, well, this thing's only an hour's change. Why don't I do a few changes and then I'll do a deployment? And instead of deploying multiple times a day, which is what we were doing at the start, we started to deploy once a day, or once a week, or maybe even once a fortnight, because that was more efficient. But if you're deploying 2 weeks worth of changes in one hit, when you have a problem with what you deployed, you've got 2 weeks worth of changes to try and find the issue. That gets harder, you get slower and slower still. There was another reason that we were getting slower. Each of those teams had their own set of prioritized backlog off work that was important for their customers, for the suppliers, for the retailers, for the internal fulfillment and logistics teams. What we discovered, though, was a lot of the business processes that we needed to change actually crossed components across multiple teams. So an example for us would be pricing. If you want to calculate the price of a product for a given retailer, you need to know the product and its price, but you also need to know who the retailer is, what state they're in, what size of business are they, what else have they ordered, do they have any promotional deals in general or with the supplier, and then you need to know who the supplier is, what state are they in, do they deliver to the state the retailer's in, and so on. And so it turns out to introduce this one feature called Calculate Product Price for a Retailer, you needed changes across 5 or 6 services across the 3 teams. And that meant you had to coordinate that work across the teams. And that work might not line up with the priorities for each team, so things would sit in queues and take even longer. So it's about then that I discovered that we had another capability of the system, morale, because morale disappeared very, very quickly. And I think, this was really the final nail in our microservices dream, right? That the fact that the business processes, the things we need to write, didn't line up with these small little services that did one thing and could be changed independently. Our stuff seemed to change in sync. And we realized that once again when we were looking at pricing, and we'd broken it up into maybe 15 or 20 little microservices. But every time a new business concept came along or a new business requirement, when New South Wales introduced the bottle deposit scheme, we had to change pricing calculations for all the bottles and anything, alcohol and soft drinks, etc. What we found is we had to change every single microservice. And we sort of realized, look, if you're going to change them all anyway, then maybe they shouldn't be microservices. Maybe they should all be in one spot. Maybe what you need is services, not microservices. So collectively, these things were making us slower and slower. It's causing tension between the teams as we argued about priorities. We were starting to argue about implementation and how things should be done. Morale was plummeting. We weren't in a good place. I don't want you to think it's all doom and gloom. It was back then. But if I skip forward to now, December 2018, it's rainbows and unicorns all the way down. We hit that deadline. We hit many more since then. Last month, we deployed 55 times to production, so roughly 2 a day. None of those deployments needed an outage. I think we had 3 low severity incidents over the month, and each of those incidents was detected and resolved in less than 30 minutes. Our cycle time for delivering new features to production is about a day. No one works long hours and no one works late hours unless they want to. So how did we get there? Well, we learned a few things and we learned them the hard way, and this is the bit where, like I said, please don't do the things we did because we did them wrong. The first one was team scale. Jumping up to 24 people and trying to wrap them around the code base and understand a domain and make changes was too much, and it made us slower. So the first thing we did was actually get smaller. And getting smaller, going from 24 to 18 with one team and one backlog, now we're at 12, the one backlog and one discussion around business priority was probably the most important thing we did to get more efficient. The second thing was technical, right? Managing those environments and configuration and all the rest of it was very difficult, and we're getting variations in environments. AWS Parameter Store released as a service in Sydney. We jumped on that. We agreed some standard patterns for how to store environment configuration, stuck them in Parameter Store, and redid all our build scripts to deploy the services and their infrastructure in a nice, consistent, standard way that everyone could use and understand, and eliminated that whole environment variability thing that was causing us so much pain. So then, having done those things, having reduced the number of priorities and reduced the conversations within the team as we got smaller, but also the conversations from the team out into the rest of the business as we tried to understand what's the business priority, what would this look like, how do we build this, gave us back our ease of change. And then the last thing, as I said, was realizing the bounded context thing. We had tried to break our system up into services that were much smaller than the actual bounded context of the things that we were working with. And trying to do that introduced all this complexity and friction into how we were working. And so sitting back and thinking about what is the real domain boundary here really helped us understand how we should carve things up. And out of that, we came up with another architecture principle. Make your services as small as they need to be to match your business capabilities, but no smaller. So here's where we are now. We've got one cluster with all the services in it. Underpinning that, there's a bunch of AWS infrastructure that can be deployed individually as needed for any given change in a consistent, reliable way. Those services encapsulate our business processes. Some of those business processes are synchronous and long-running. Some of them are short and bursty. Some of them are overnight batch jobs that take a couple of hours. Collectively, they make up the business processes that we needed to support the business growth. So our architecture, it doesn't look like that, right? It actually looks a lot like the thing we started with, the original monolith, but it's distributed. We can deploy things independently. So I like to call it a distributed monolith. And that's a good thing, right? Because that's what we needed. So to summarize, here are the main things we learned. And this one's probably, I think this is key to our growth and to my personal growth. As technologists, you need to spend most of your time understanding the business and how the business works and what they need and what they're doing and all of that. And then use that information to evolve your domain model and your architecture plans and everything else. One size does not fit all. Secondly, build your core IP and only your core IP. For us, borrow, open source, followed by SaaS, followed by license. And lastly, only if it's core IP would we build it. And most importantly, make your services as small as they need to be and no smaller. Definitely not micro. Thank you.